We all know about the space race, when the United States and the Soviet Union battled it out to become the world's leading power in extraterrestrial exploration. What's less discussed, though, is the race to explore the depths of our own planet. While the US is widely said to have won the space race, it was the Soviets who emerged victorious in this other battle. It was they who created the Kola Superdeep Borehole, the deepest hole ever drilled. Uncovering Earth's secrets. A journey into its deepest hole, uncovering Earth's secrets. A journey into its deepest hole. The Americans started this race to the bottom towards the end of the 1950s with the launch of Project Mohole. This was a plan to drill through the seafloor off the coast of Mexico's Guadalupe Island in order to reach the mantle of the Earth to take a sample. The project was undoubtedly an ambitious one, but it faced a lot of obstacles. Drilling underwater is no easy task, and it required engineers to get creative in order to find a solution. One problem the experts faced when planning for this underwater drilling effort was the prospect of the vessel housing the drill spinning out of control. That could have been disastrous, but an innovative concept called dynamic positioning was employed to deal with the issue. Basically, propellers facing in the opposite direction to the rotation of the drill were fixed to the hull of the vessel. These were switched on while boring was being carried out to stop the craft spinning. That meant the ship could stay in position over the hole. By 1961, Project Mohole had succeeded in boring a hole of 601 feet in depth at a depth of 11,700 feet below sea level. In another reality, that would have marked only the start of the project's achievements, but, as things really played out, it was ironically its high point. Project Mohole soon succumbed to the realities of American politics. Congress cut off the initiative's funding in 1966, following a period of internal disagreement about what the goals of the project actually were. The whole thing is just a footnote in history now. The Soviet attempt came after all this, in 1970. They started drilling in an area of Russia called Murmansk, which isn't far from the border with Norway. Their project was the Kola Superdeep Borehole, though it actually consisted of several holes rather than just one. It's one of these holes, one known as SG3, that's considered to be the deepest ever to be drilled. It cut deeper into the Earth's crust than any other attempt in history, and its record remains in place today. You might wonder why any country would go to the trouble of initiating difficult projects like this. Why is it so important to dig deeply into the Earth's crust? Was the whole thing just for bragging rights within the context of the Cold War? Or was it something more important? It was, of course, the latter. This wasn't just a project for show. It had some solid scientific aims. There's a lot we need to learn about the inner workings of our planet, and the Kola Superdeep Borehole project marked a significant effort to really grapple with those mysteries. Standing above it from the surface, the boreholes at the Kola site would have been quite unassuming. Their diameters were only 9 inches, which gave no sign of the hole's true depth. But on and on they went, deep into the Earth. The deepest of these, SG3, reached the crazy depth of 40,230 feet. It's difficult to conceptualize that without comparing it to anything else for scale, so we'll let you know that the summit of Mount Everest is 29,035 feet above sea level. In fact, you could stack Japan's Mount Fuji, which stands at 12,388 feet tall, on top of Mount Everest, and you still wouldn't have a measurement equivalent to SG3's depth. The borehole was deeper than the Mariana Trench, too, which, at 36,201 feet, is the open ocean's lowest point. All of this is to say, SG3 was deep. Its creation marked quite the achievement from an engineering perspective, and it would eventually lead to some fascinating discoveries about our planet. As impressive as the Kola Superdeep Borehole was, though, we need to retain our sense of the Earth's scale, too. SG3 was deep, but on a planetary scale it was but a scratch. Our planet's continental crust, which is the very ground we walk upon, has a general depth of roughly 25 miles. That's about 132,000 feet, so SG3 still had quite a way to go. And that's just the crust. The Earth's mantle, the layer which sits beneath the crust, is about 1,800 miles thick. And underneath that is the outer core, which goes on for roughly 1,400 miles. The inner core, which sits at the center of it all, has a radius of 758 miles or so. So, SG3 was incredibly deep from one perspective and not at all from another. Viewed on planetary scale, the record-breaking borehole cuts into a third of the Earth's crust and a mere 0.2% of the overall distance to the planet's center. Achieving this depth of 40,230 feet was an extremely time-consuming endeavor for everyone involved in the project. Drilling works kicked off on May 24, 1970, but it was almost 2 decades later that the record-breaking depth was finally reached. The intention of the project from its inception was to go as deep as humanly possible. By 1979, the project team had managed to go further than any previous effort, but it was a full decade later that they hit 40,230 feet. The feat was achieved using a special technique known as rotary drilling, which the online magazine Interesting Engineering described in a piece published on January 2, 2024. The article's writer, Christopher McFadden, explained, the project used a branching structure, meaning the main borehole had several side holes branching off at various depths. This technique is widely used in the oil and gas industry. It employs a rotary drill bit attached to a drill string and a series of drill pipes that transmit rotational force to the bit from the surface. The drill bit is usually lubricated using special fluids called muds. These are circulated through the drill pipe and out of the drill bit and provide cooling, pressure control, cutting removal, and lubrication to aid the drill process. McFadden went on to explain that the drill bits employed for the task can be made from a variety of hardy materials, including diamond and tungsten carbide. But, tough as they were, their limits were tested by the extreme conditions they encountered. In order to deal with that, the engineers needed to think up some fixes. McFadden wrote, the Kola project had the unique feature of a branching structure, making the borehole resemble a sort of tree branch or root-like structure underground. At specific depths, side holes branched off from the main borehole. This allowed for a more thorough exploration of the Earth's crust without starting a new borehole from the surface. The engineers' innovations were very effective, but by 1989, at 40,230 feet, the project could continue no further. At this depth into the Earth's crust, temperatures had become so hot that the equipment could function no more. Scientists had expected that temperatures would be something like 212 degrees Fahrenheit at this depth, but they'd underestimated what they were up against. In actual fact, they hit 356 degrees Fahrenheit. It was simply too much. When you consider that, around this same point in history, humankind was successfully launching satellites into space, it can seem kind of strange to think we weren't able to go much further beyond 40,000 feet deep into our own planet's crust. After all, the Voyager 1 space probe that was sent to space in 1977 is now literally billions of miles away from Earth. Why, then, is it such an issue boring into the planet's crust? Ostensibly, to the untrained eye, it might look like a simpler task than interstellar space exploration. But, in reality, drilling gets really complicated past a certain point. Things got especially difficult for the Kola Superdeep Borehole when the drill got to about 4.3 miles below the surface during the 70s. Until this point, the equipment was able to cut through the granite in its path with relative ease. But here, at this depth, things got much harder. Drill bits started to break, and the scientists were forced to change course. As a consequence, Dr. Ulrich Harms of the German Research Center for Geosciences told how stuff works. Several drill paths were drilled until a pretty vertical path was finally achieved. The project continued as far as it could go, deeper into the Earth and its increasingly hot temperatures. The scientists were surprised by the intense conditions present past a depth of 10,000 feet, as the models they'd been working with up until that point had never suggested it would be like this down there. This, as a matter of fact, was a major discovery. The intensity of the heat was far greater than anyone had expected. At maximum depth it was about 144 degrees Fahrenheit hotter than anticipated, which is a pretty significant margin. The specific properties of the rock the scientists were boring through past a certain point were similarly surprising. After about 14,800 feet, the rock was more porous and permeable than expected. These surprising conditions of the rock, coupled with the hotter than expected temperatures down there, meant drilling became increasingly difficult. The rock was acting more like plastic at this depth, as opposed to it being as solid as scientists had expected. The drill bits consequently really struggled to work through it. The high temperatures were too much for the equipment to bear, so the depth of 40,230 feet was as far as they got. As noted, this depth was achieved in 1989. But that didn't quite mark the end of the project, which pushed on for another 3 years. By the time the plug was pulled on the project in 1992, the Soviet Union itself had collapsed, and an era had come to an end. For years the site of the boreholes lay in obscurity before they were sealed in the mid-2000s. If you ventured to the site of the project today, you wouldn't find much of interest there. The place is little more than a ruin these days, the significance of the work that once took place there totally lost to time. The borehole itself is covered by a cap. You'd barely even notice it. It's strange to consider that this was the fate of the site. The Kola Superdeep Borehole was arguably among the Soviet Union's greatest ever achievements in science, but little is known about it among the wider public. So, why is the Kola Superdeep Borehole considered to be so important? Why should people know about it? And, more broadly, what is to be gained from boring holes into the Earth's crust at all? Well, there are many reasons. On the one hand, you have pretty straightforward advantages. Deep holes in the crust allow for resource extraction, whether that means metals or fossil fuels. But beyond that, the scientific possibilities of deep holes are tantalizing. Drilling incredibly deep holes into the Earth's crust can help scientists to better understand geohazards, such as volcanic eruptions and earthquakes. What's more, the findings might shed new light on life on Earth and how it evolved. And boring holes into the crust can also allow experts to investigate the changes to the environment that have taken place. This is really important work, as it means they can make more accurate projections about what awaits us in the future. Dr. Harms has spoken in more detail about the advantages seismologists specifically can gain from deep boreholes. He told how things work. One example in detail is that observations very close to an earthquake zone allow researchers to monitor the initiation and propagation of even the tiniest earthquake in response to stress and strain. We want to recover these near-field physical, chemical, and mechanical data to fundamentally understand these processes that cannot be simplified in lab experiments or computer models. As for the Kola Superdeep Borehole specifically, there were numerous discoveries made. As we've already mentioned, the temperatures beneath the surface were way hotter than anyone ever expected, which meant the temperature map of the interior of our planet was updated. Beyond that, scientists were also astonished to discover that the Conrad discontinuity wasn't present along the drill's course. The Conrad discontinuity is a theorized boundary in which granite in the Earth's crust transitions into basalt. As McFadden wrote, one of the most surprising discoveries was the absence of the expected transition from granite to basalt between 3 and 6 kilometers below the surface. This transition, known as the Conrad discontinuity, was previously believed to exist based on seismic reflection surveys. Although a discontinuity has been detected beneath all of the continents, the drill at Kola never encountered the proposed layer of basalt. Instead, it found that the granitic rock extended beyond the 12-kilometer point. Another major finding that resulted from the Kola drilling was that water, in its liquid form, is found at a much greater depth than it was ever previously thought possible. Dr. Harms told how stuff works. One of the unexpected results was certainly the occurrence of open saline water-filled cracks, documenting that the crust is not dense, but that pathways exist allowing fluids to flow. Scientists have a theory about where this water may have come from. They think it might have derived from rock crystals, which were compressed by the immense forces acting on them deep beneath the surface of the Earth. Arguably the most intriguing discovery made by the Kola project scientists was the suggestion of life at a depth of 3 or 4 miles beneath the surface. A series of fossils were found, some of which were around 2 billion years old. They belonged to unicellular marine organisms. McFadden described them as microscopic plankton fossils in his piece. He noted that the rocks they were found in would be about 2.5 billion years old, making them some of the oldest fossils ever discovered on Earth. As well as signs of life, significant supplies of hydrogen were also noted by the scientists. The mud that emerged from the hole was, according to McFadden, once noted to be boiling with hydrogen. Apparently, the likely explanation for the presence of this hydrogen was something called serpentinization, which McFadden tried to explain. He wrote, "This is the process of hot water in the Earth's crust, hydrothermal, altering minerals in rocks, transforming Fe-Mg, iron magnesium, silicates such as olivine, pyrozine, or amphiboles contained in ultramafic, high silica content, rocks into serpentine minerals." One of the byproducts of this process is the production of free hydrogen. That might not mean a lot to us laypeople, but experts were obviously fascinated to observe the hydrogen at the site of the borehole. The scientific community has so much to learn from the discoveries at the Kola Superdeep Borehole, even today. But not everyone has taken such a rational view of the work that was once going on there. During the time in which the site was active, sensationalist newspaper reports began to appear with a warning. They raised the possibility that the scientists, by drilling so deep, were potentially about to enter hell. Some reports went on to try and back up the fantastical claim by asserting that audio recording equipment had detected a strange sound. It was almost like, the writers claimed, the awful din of human screams. The suggestion, of course, was that it was the sound of the suffering souls condemned to an eternity in hell. You can find conspiratorial videos on YouTube today still peddling these absurd claims. Obviously, a more rationally minded person would reject the claims that scientists had broken past the boundary separating our realm and hell. But if there really was a sound detected by the recording equipment, what could explain it? There must be an explanation. Well, in actual fact, the news reports were wrong about even this. There had never been any recording equipment that detected any sound. If the drill could barely function with the heat down there, how could a microphone? The answer is that it couldn't. No recording devices were ever sent down there. Back to the actual science, and there's the question of whether or not it will ever be possible to surpass the record depth set by the Kola Superdeep Borehole. According to Dr. Harms, it's definitely possible. Just don't hold your breath. It'll take some time. He claimed, digging deeper than 12 kilometers, 7.45 miles, depends on two critical factors: temperature and borehole stability, the latter being dependent on stress, strain, and drilling fluid composition and weight. The development of some very hardy equipment will be necessary for that. Ideally, scientists will eventually manage to bore down into the Earth's mantle. That's where some amazing discoveries stand to be made. We still have a lot to learn about the mantle, and much debate about it still exists today. Managing to reach it with a drill would be a massive step. Unlocking the secrets of the mantle would potentially have profound impacts upon our scientific understanding of all kinds of things. We might learn critical information about the history of the very biosphere we inhabit, as well as what goes on underneath it. So, have any other projects of this nature been launched since the end of the Kola Superdeep Borehole? Well, attempts have been made to bore deeply into the Earth by Sweden, Austria, and Germany, but none have ever managed to reach the depth achieved by the Soviets. The Chinese, though, are embarking on their own project. According to The Guardian, they're doing it for both scientific and economic reasons. They might, the thinking goes, find oil or gas down there. The Chinese borehole, Shendi Take 1, sits in the Taklamakan Desert, which itself lies in the Tarim Basin. At its inception, the project was intended to reach a depth of about 36,400 feet. That's still less than the Kola Superdeep Borehole, whose record looks set to ensure for a while longer yet. Still, in terms of Chinese history, this effort is record-breaking. Wang Chunxing is the chief expert of the company overseeing the Tarim oil field drilling, the China National Petroleum Corporation, CNPC. He told the Xinhua news agency, it is the first time that China has drilled a vertical borehole over 10,000 meters deep. The Tarim Basin, situated as it is in the middle of the Tianshan and the Kunlun Mountains, is an extremely troublesome area for scientists to conduct exploratory works. Conditions there are very harsh, and the situation underground is complex. And, just as the Kola Superdeep Borehole ran into issues the deeper it went, the same can be expected for Shendi Take 1. The temperatures will be extremely high and the pressures intense. Speaking to Xinhua, another expert from the Chinese Academy of Engineering expressed a metaphor to detail the issues facing the project. As Sun Jinxing put it, the construction difficulty of the drilling project can be compared to a big truck driving on two thin steel cables. Some extremely heavy machinery will be employed for the task, weighing something like 2,200 tons in total. It won't be easy, and the harsh conditions of the Taklamakan Desert itself will only add to the challenge. According to The Guardian, the Shendi Take 1 initiative is part of a wider effort on the part of China to break new ground in a range of areas. The country is hoping to explore space to a greater extent in future, for instance, while it's also looking to lead the way in investigating the Earth itself. President Xi Jinping is also trying to increase the domestic energy supply in his country. That has meant companies within China are incentivized to explore beneath the surface in search of new supplies. There are parts of China which are already known to be rich in natural resources. The region of Xinjiang, for example, is home to oil and mineral deposits. And last year, oil and gas was discovered in the Tarim Basin itself. The fuel was located very deep down, though. It was reportedly discovered at a depth of roughly 28,000 feet beneath the surface, so the need for super deep drilling projects in China is clear to see. But, of course, there's much more to be gained from such deep drilling than simply discovering supplies of fuel and minerals. There's much to be learned scientifically too, as the CNPC has itself acknowledged in a public statement. If experts involved in the project are to be believed, Shendi Take 1 has the potential to make vital discoveries about our planet. There's still so much to learn about the Earth, and projects like this can go some way towards enlightening us. Thank you for watching. Please don't forget to like and subscribe.